Okay, in this lesson I'm going to talk to you about inverse trig functions and how to evaluate them. And what we first need to recall is something about the graphs and the restricted domains. And so as we read through these notes, we can see that when we do evaluate inverse trig functions, we have to make sure that the answers lie within the restricted areas. For example, we know that the tangent of pi over 4 is equal to 1, and the tangent of 5 pi over 4 is also equal to 1. So when we're asked to evaluate the arctan of 1, the only value of theta that falls within the restrictions of negative pi over 2 to pi over 2 is pi over 4. So we have to throw out 5 pi over 4 as a possible candidate for that answer. So let's take a look at a few examples. We're going to look at these 4 examples first. I'm going to start with the arc cosine square root 2 over 2. And what this simply means is what angle produced that ratio. And again, we have to stay within the restrictions because there's infinitely many angles that would produce this ratio. So our options are going to be first and second quadrant because those are where the restricted values are. And as we look at second quadrant, we can see that this one gets disqualified as a result of the fact that our ratio will be negative. So when we look at first quadrant, we're going to see that the angle that produced that ratio is pi over 4. So that is our answer. The second question, again, if we were to rephrase this, we're looking for the angle that produced the ratio negative 1. Since negative 1 happens to be one of the quadrantal points and the cosine maps itself to the x value, then the only possible candidate would be pi. Third question, again, now we're looking for the angle that produces 0. If you understand the parent graph at all, you know that the answer will be 0, but let's just confirm why. When we create our restricted areas, which is from negative pi over 2 to positive pi over 2, and we look at those quadrantal points, we know that the tangent ratio is sine over cosine theta, and so we're looking for the angle, or excuse me, the ratio that produces 0 over 1, which is going to be equal to 0. And the last question on this page is we're looking for the angle that produces the ratio negative 1. Again, let's take a look at our restricted areas, which is going to be, again, from negative pi over 2 to positive pi over 2. And again, our only two options would be these two angles. We know that the tangent of 45 degrees or pi over 4 is equal to 1. So when we create our special right triangle ratios there, we are going to have to disqualify the first quadrant because that produces a positive 1. And so our answer is going to be negative pi over 4. Okay, let's take a look at 4 more questions. Same thing. We're looking for the ratio, or the angle that produces the ratio, square root of 3 over 2. And the restricted area is first and fourth quadrant because the restricted values for sine, inverse sine, is negative pi over 2 to 2, pi over 2. And so in the fourth quadrant, though, the sign is negative, so we're going to just focus in on the first quadrant, create the special right triangle, which is a 30, 60, 90, and the angle that produces that ratio is pi over 3. For cosine, the restricted area is different. It's from 0 to pi. In second quadrant, the cosine is negative, so we're going to focus in on the first quadrant. 1/2 comes off of the 30, 60, 90 degree triangle, so let's build that triangle. We want the ratio for cosine to be 1 over 2, so side adjacent and side hypotenuse have to be in the right place. And the angle, therefore, is 60 degrees or pi over 3. For sine, we were looking for the angle that produces this negative ratio, so the first quadrant is pretty much out of the question. And so when we build that triangle in the fourth quadrant, we get negative pi over 4. Now keep in mind, we're not talking about reference angles, which are always positive. We're talking about the angle within the restricted areas. Cosine 0 has to be a quadrantal point. Which one of those produces a 0? Well, if we label those points, we're looking at the x value, and that would have to be pi over 2. Okay, our next 4 questions. Again, with number 5, we're looking for an angle that produces a ratio of negative 1/2, and it would have to be fourth quadrant. And the angle that produces that would be 30 degrees, or pi over 6, and it would be negative pi over 6 because it's in the fourth quadrant. All right, the angle that produces the ratio of 1, that one we need to commit to memory, is always 45 degrees. And so it being a positive one, it will be committed to the first quadrant. And that's our 45, 45, 90 degree triangle that we've built. And again, the angle there is going to be pi over 4. And the next question, again, we're looking at a negative ratio, which is going to have to be second quadrant because cosine is negative in the second quadrant. So we build that ratio. That's also, again, one of our special right 30, 60, 90 degree triangles. The angle that produced that ratio is going to be pi over 3, but in this case we're looking for the angle, not the reference angle. So the answer will be 5 pi over 6. And lastly, if we take a look at this one, we're looking for an angle that produces a ratio of negative square root 3. Well, square root 3 comes off of a 30, 60, 90 degree triangle, so let's build that. And we can see that this is going to be negative pi over 3. And again, here's some more examples. These are a little bit different. These are called composition functions. And as we look at these now, we're really going to be starting from the inside and moving out. The angle that produced the ratio 1/2 is pi over 6. And so now we're going to take the cosine of pi over 6. And again, if we need to, we can build the triangle. The cosine will be square root 3 over 2. Next, the cosine of pi over 4 is going to equal 1 over the square root of 2. And then when we take inverse sine, 1 over square root 2. Again, that's going to be first quadrant, and the angle will be pi over 4. Inverse tan 1, again, that's going to be 45 degrees, or pi over 4. And so when we take the sine of pi over 4, we can use the same triangle. We get the square root of 2 over 2. And these last few questions are the same thing. Again, the reason why we can take cosine 7 pi over 4 is because it's not inverse. So that will be, if we draw that, that'll be fourth quadrant. And the reference angle will be pi over 4. And then when we take the cosine of that, we're going to get positive 1 over the square root of 2. And now when we take the inverse of that, it kind of brings us back to the restricted areas. And again, because it's a positive ratio, it'll be first quadrant. And that angle will equal pi over 4. Next, the inverse sine of 1/2 is going to be first quadrant. The angle that produced that ratio is pi over 6. And now we have that 2 there. Let's take a look at what happens with that 2. We're just going to double pi over 6, which changes out to pi over 3. And the cosine of pi over 3 is going to equal 1/2 as well. The last one on this page, the tan, inverse tan of -1, we should know by now that that's going to be negative pi over 4. And then when we take the sine of negative pi over 4, it's going to equal negative square root 2 over 2. Okay, here's the last few. Let's begin with cosine pi over 3. That's equal to 1/2. The angle that produced that ratio is going to be pi over 6. Next, the tangent of pi over 4 we should know now is 1. So the arc cosine of 1 is going to equal 0 because the cosine maps itself to the y value. Hey there. Hang on a second, sweetie. I'm recording something. Sorry about that interruption. I had a student walk in the door. At any rate, we got one more question to do, and so let's go ahead and do it. The cosine of pi is equal to -1, so the arctan of -1 is going to equal negative pi over 4. And that concludes this lesson.